Okay, thank you, everyone. It's welcome to here to share some interesting experience about how to use Linux in the automotive system, because we have several years about it. Use the Linux in our own system, so I think it's interesting. We met some problems, and it will show how to fix these problems, how to fix them, and how to handle them. Okay. First, introduce myself, and I'm from a China company, Huawei, and my company is mainly help OEM to make their system more intelligent. So we were talking about this today, about intelligent system, how to use Linux. Okay, let's start. Yeah, it's very normal that what is Linux? Yes, everyone knows Linux. So what we want to say is that, yeah, Linux is very successful, so we want to use it. And it's not young, and it's more than 30 years, and has a spiritual leader. What we want to say is that Linux is widely used for mobile phone, just like in China, there are Harmony OS. It's yeah, our company is supporting this operating system. And Android, they are all use Linux as the kernel. And it's very famous for server, just like Red Hat. Ubuntu, okay, because in China, we still build OpenOLA for the operating system. That is blue line, that our company, yes, our company is an active contributor to Linux. In recent years, we always be the top 3 in many versions. So yes, I think I have a lot of colleagues working for Linux, and we know how to make Linux better and more useful. Now, Linux is young in automotive system because I think it's not only in Japan. It's also in China. We also discussion about how to use Linux for IVI, for cluster, automotive self-driving, ADAS, etc. So let's go ahead. Why Linux is so important for automotive system? Let me think about it. I think the biggest challenge for the automotive system is that our car is becoming more smarter. That is the main challenge and the main opportunity for the Linux. So it's mainly talking about intelligence driving and intelligence cockpit. And we can see that because of the intelligence, we use big SoC, big chip, power chip. We use heterogeneous computing, CPU, GPU, NPU together. And we also use MMU. I think several years ago, MCU didn't have MMU. And also, the software is a very huge code, more than 10 million. And the software need to update every day. It's intelligent system. And also, it has rich ecosystem, just like smartphone and HPC computing. So as an intelligent system, it needs strong toolchain. It's friendly to the developer, strong security, defending against a hacker attack. So it's a lot of problem for the intelligent system. So Linux is very suitable for intelligent system. That's why I think in China, that's why we choose Linux as the intelligent system for automotive. So you can see that, this picture. Yeah, now the car looks like, it's Chinese, okay. And the car is like smartphone. I think they look like the same for intelligence area. Of course, Linux is very outstanding performance in security and development. We like to use Kernel, UBCN, memory leak, CFI, C groups, perf, and more, GDB, ftrace, keydump. They are very, very useful for automotive system because we want to debugging the problem, debugging the bugs. And when we met the problems, and use these tools, it helps us solve the problems as quick as possible. So this is the advantage of Linux. Yes, it's very good. And Linux is also enhanced in real-time, heterogeneous computing, and reliability for automotive system. Yes, this session have been discussed already for several years. I remember that maybe 3 or 4 years ago, there are a topic about how to make the Linux real-time, more real-time. So there is the real-time patches. It's already released in Linux kernel, and you can apply them. You can see the picture that when you apply the real-time patches, the system will much better for real-time. Okay, and we also developed several features just like SVA, share virtual memory address, is developed by our own team, and we try to improve the memory efficiency and performance for the heterogeneous computing. Because for the heterogeneous computing, the shared memory is very important for the GPU, CPU working together. So this feature is mainly for these features. You can see the source code from here, and it's already in the GitHub. And we also do something for the RAS, reliability, availability, and servability. This is from server, just like RAS. And it's very important because we want to handle the exception for the memory. So it's the best architecture, I think, till now. And also, we support NMI. As you know that in the ARM architecture, there are no NMI, non-maskable interrupt. So we need to support it. It's because when you system in the while loop, it's dead while loop. It's very important for the interrupt to stop the system and handle the errors. So these all features, both are very, everyone's very important for the automotive system. Yes, we can see the last three features, we already use it in the smart driving system for some vehicles in China, mainland. You can see they are already, you can buy it, and already it's a production. So it means that Linux could work for the automotive system. Before we work, our works, I think Linux already used for automotive intelligence system. Yes, Tesla, I think it's very famous that Tesla used Linux to build autopilot and cockpit system. You can see the kernels from the GitHub, and autopilot and cockpit. And there is a famous picture from the internet. It said that Tesla software stack. Yes, it's interesting. But there are another interesting news that it's from New York Times, published in Saturday, 2022. And the picture, the news is, yes, the Dawn project founder, Dan Howard, posted an advertisement questioning that the safety of the FSD system. So interesting is that Dan Howard is the CEO of the Green Hill. Green Hill is a microkernel distribution. So I think it means that Linux is not safety. Yeah, but it's true. The truth is, up to now, Linux still cannot obtain the functional safety certificate for ISO 26262. Yeah, it's true. Okay, inside. Because about 3 or 4 years ago, our team, and I have a leading an innovation team to make the system for the, build a system for the automotive. So about 3 or 4 years ago, we are starting to investigate, to analyze why Linux is not, whether we could certificate Linux for ISO 26262. So at last, yes, we have some results. First, ISO 26262 do not define a direct, simple solution for complexity software. It's in the standard. Yes, if you want to read the standard, know how to do it. Sorry, no ways. So the second, 26262 is infeasible to direct apply on Linux, including IEC 61508. They are the same. There are several reasons. I think the reason is that ISO 26262 is based upon V model. Yes, everyone, I think a lot of us knows what is V model. I want to describe it more. V model for reference process model. Second, V model is waterfall software development mode. Yes, waterfalls. So yes, our in Linux system, we always like to talk about DevOps. DevOps, I think, is totally different from waterfall. Third, V model is expensive. Yes, it's very, very expensive. Each line about $10 or $15 for each line code. It's the truth. And the last one, V model could not support a component which more than 1 million codes. Okay, Linux is more than 20 million codes. So it means that if we want to direct use ISO 26262. On Linux, maybe we have no ways because of these rules, these reasons. Okay, let me look at the Linux development creed. Open and collaboration. Yeah, this line is Linux how to developing, and the long line means how to contribution, how to release the new version. You can see it's very complexity. Yeah. Yes, the principle is that the iteration of Linux is very, very fast. Every 2 months, we will release a new stable version. Every year, the community will choose a stable version as a LTS, long stable version. The LTS version will accept more than 100 patches about bug fix every week. It's very difficult to maintain a 5 years LTS version, more than 5 years. Yes. So it means that fast and continuous daily iterations are the biggest advantage for the Linux. So Linux is very new. It could update very soon. New features will update very soon. But traditional auto software don't like it, because in the automotive system, we like the stable software. The software could contain more than 10 years, it's best. Otherwise, we need to pay more money to update the software. Yeah, no one liked it. So after all, we can say that Linux is challenged by the functional safety. There's a lot of reasons. The reason of weakness of Linux safety, we can see it. First one, monolithic. All the drivers run within and distributed with the kernel. You can see, especially the drivers. In Linux kernel, 60% of the source code is drivers, so they are working together in the same address of the memory. It's very, very dangerous for the functional safety. No one will accept it. And the second one, no partition. About 100 more than subsystems run within kernel, just like networking, memory management, architecture. So it's dangerous. Also, it's dangerous because one component is panic. All systems could not work. And next, the code maintenance challenges. Because it's very long, the exciting spec may be inconsistent with current source code. Because a lot of source code is maybe about 10 years ago. You can read it, but you don't know how to use it. You don't know why they will write this code like this. So this is the reason you could not modify it. And missing comprehensive and up-to-date architecture and design. A lot of architecture is designed not by a very good architecture. Maybe they are updating every year. And some long time exists, 10 years source code is hard to understand and lack of performance. If you use Linux, you will see all of these problems. And incomplete test at all levels, just like verification test, integration test, unit test. Because we have tried to analyze that in our source code, maybe about 30% of the source code could be test, coverage test, UT and ST. Other 70% source code, we could not cover it. So it's the problem. Insufficient test coverage. Okay, and next, a lot of regression bugs. Sometimes you will see that some guys send a patch. He said, I fixed bugs. Okay, also, several days later, we will find he had introduced another new bugs. Bugs and bugs. That's why the Linux likes so many contributors together. Yeah, it's a really problem. And next, unfollow MISRA. Everyone knows that in the automotive system, MISRA is very important. We should follow the MISRA standard to write our source code, especially C and C++. But MISRA is not accepted in Linux. No one will care about it because we are hacker. No one likes MISRA. And next, unreliable upstream code quality. Because a lot of patches and source codes are upstream and accepted by the maintainer. The maintainer checked source code by experience, not by the whole test. It's very dangerous. It may miss some bugs. So it's true. Because it means that CI is very important. And next, lack of safety qualified tools, because till now, a lot of safety qualified tools are commercial. You need to pay for a lot of money to use it. But these tools, you cannot directly use on Linux, because these tools could only handle a small component of the software. If you tell the tools company, said, I want to use it in Linux, he will say, okay, you need to pay a lot of money to modify the tools. Yeah, it's a problem. The last one, GPL license. I mean, all the modification will be free for community. So if you invest a lot of money for the Linux, so you will be open it and share it to the community. Yeah, it's good, if you have enough money. So the right part is the architecture of the Linux system. It's very famous. You can see it in the internet. Okay, let's think about it. There are a lot of problems, yes, but there are some dessert, because if we have a Linux certification, there are a lot of possible advantage. We call it a dessert. You can see, as a business company, we like it because it's very effective. First one, rich hardware platform support. Because the Linux thousands of chips platform could enable by the Linux. Yes, we can use it. We don't need to worry about new platform, whether it could work or not. And second, rich software ecosystem support. Yes, Linux is built for a lot of systems, just like server, just like a mobile phone. So you can see all the ecosystem is based on the Linux. You can get all the ecosystem. It's very easy to use and test the latest innovation technology. And third, possibly scalability and performance. Yeah, it's true. But Linux is the scale of Linux is updating maybe every year and every month. So the performance is better and better because it's a monolithic kernel. And so cheap license fee and development cost. So you don't need to pay for any license for the Linux. You just need to hire some development and just hire a team and to handle the Linux kernel. And the last one, reduce the time to market, because Linux is already used in a lot of place, so you can use it, and it's time very short to use in the market. That's why as a business company, we all like Linux to build the first version of our system. But as we see, Linux is very good. But and we can see that Linux Foundation are continually solving the safety weakness. There are two famous projects, I think. I think these two projects are very good. The first one is CO2 Linux MP. This project is already finished. It's about 2015. And you can see all the series and all the messages by the internet. It's all open and public. And it's very good. It's a good. I think it's a good project. It gave us a new innovation theory that how to prove Linux is certification. But that's all. No one will use it for the true production till now. And the second project in ELISA is very famous. I think it's still ongoing in recent years, and you can see a lot of message on the web. Also, these two projects is very good, and a lot of companies enter the project to work together, but not ready for the commercial yet. I think if you want to build a business for the Linux, I think this open source project could not help, maybe could not help you. Okay, we can see that many commercial companies are investing for safety of Linux too. Not only the Linux Foundation, there are a lot of companies, just like BMW. They also investigate CO, just like two projects, last page. And another, you can see that Intel has several years ago, I think 3 or 4 years ago, they announced that they have a safety critical project for Linux OS, but only announced. Yes, I think it's only announced. So, and that Red Hat said that it will release a Linux kernel version for ACOB. Yes, this year in China, in a lot of conferences, they always say the same message, but I think I was waiting. I was waiting them to give us a release version. It's very good. We were waiting for the production. And then SUSE also announced that it will try to give a certificate safety Linux kernel version. Yeah. So SUSE, Red Hat, and Intel, it means that they are investing for the safety of the Linux. But there are no exciting products now available in the market now, and because we could only see it in the news, in the web. But it's still, till now, there is no safety Linux version release. So we just need to wait. Okay, recommendation. Okay, we will try to give some recommendation that how to build a safety kernel. Yeah, it's very interesting because we have request the same question, just the TUV, and we have discussion several times and give a roadmap, give details of the project. That it's a very, really huge work for the Linux to build a safety kernel. Summary. It is impossible to qualify Linux without significant changes. If you want to make the Linux for safety, you need to do a lot of work. There's no other ways to do it if you want to make it simple and make no significant changes. Step 1, make a minimal kernel version. Because Linux has more than 20 million codes. So the first, you need to cut most of them. Maybe because in your system, most of the source code will not be used, indeed. So the first, you need to analyze and remove the unneeded subsystem, unneeded source code, and make the Linux much more smaller. Maybe several millions code. Yeah, this is the first step. And the second, you need to rework the driver architecture, because the driver working with the Linux kernel together is very dangerous. So there are a lot of user space driver architecture. You can use them and modify your driver and move the driver to the user level so that the driver panic could not affect the kernel. It's very, very important. And then we will remove the unused features. If you don't need the software stack, you could remove it. Just like network stack, you can remove it. If you don't need the I/O stack, just like SATA, SAS, you can remove the SATA stack. Yes, all this work could make the kernel smaller. And rework your code so that it could fit MISRA. It's very, very important because all the certification company says that as a C language, compile language, you need to follow the MISRA. So you need to modify a lot of source code by the MISRA standard. It's a really hard work, but you can do it. I think it's not. It's a lot of you need a lot of huge work. The step 2, then you have get a very small Linux kernel version. It's possible, and then you need to maintain the new version. I think it's the nightmare. It's very, very challenging because first one, you need to check the new patches every day, analyze the scenarios and effect, because you know that the Linux the mainline tree has a lot of patches every day. You need to you need to analyze whether the patch should be used in your system, in your own Linux kernel version. And then if and at that time, you cannot apply the patch directly. So you need to modify the patches and modify it. It's a lot of work. And step 3, test coverage for each line of the code. Because as an ACOB, you need to coverage about 100% of the source code. So you need to use a lot of toolchains, just like UTST, analyze the interface, analyze the test boundary. So yeah, I think if you have enough money, you can hire more person to do that. It could be done. And the last, after all, the last issues upstream, because the system need to update, and you have your own patches, you need to maintain it for a long time. So you need upstream. But at this time, you get a version. It looks like a monster version of the Linux. It's very strange. So in the world, no one can maintain the version. So you have to maintain the version by yourself. If you upstream, I think it's impossible. And then you will face the two problems. The second problem, GPL. Maybe you can share it to the public, share it to the global, and everyone can use it because it's safety certified. Yeah, it's very good. All this means that huge and long-term investment. Is it worth? You can ask your manager, ask your CTO, is it worth? Yeah, it is business issues. It's a business issues. It's not a technical issues. So we give our own opinions. One, OS safety is not the top priority of the smart driving system. You can use smart driving system, you can use cluster, and depend on your production. The first, the top issues of the smart driving company, we can see what are they, what was the true issues of them. The first one, you can see, as a smart driving company, they are solving corner cases because the company is trying to make the system more smarter and smarter. The second, reduce hardware cost and mass production. Yeah, every company needs to live, so they need to, if it's too expensive, no one will buy it. And third one, vision or HD maps. We all know that the Tesla used the camera, but Waymo used the radar. So these two ways, you should choose one ways. It means that you will destruct your architecture. The fourth, driving simulation. You need to build your simulation to make your system more smart. And then we were talking about that operating system to change real-time, efficient, safety, security, convenience, and then data-driven SOA architecture. So you can see that OS safety is important, but there are many, many more important things to do as a smart driving company. So as a company, as a leader of the company, you may think we should put more money on the other important things, but not only the safety. And then we will see that 5 levels of vehicle autonomy is that till now, currently, in all the world, including Tesla, including in China, a lot of smart country, smart vehicle, we all announced that we are L2 plus smart driving. No one will get L3 for production, for commercial. So L2 plus system, L2 plus smart driving means it's a best effort system. It's a best effort. So if we want to enter L3 and L4, it's an autonomous driving. It means that the system must be deterministic system. So I think as current stage, I think L2 plus smart driving is a best effort system. Linux is good. Linux is also a best effort Linux kernel. Okay, option 2. Safety is a system property. Yeah. Just like the picture you can see, it's a very famous picture, just like if you want to get a COB component, you can separate the component to 2 parts. The big part is QM, just like Linux, and the small part is just like a safety checker, a safety monitor. They could work together to build a system, a COB system. It's possible, yeah. A lot of companies say that it's possible. But system safety is good, but not easy to deploy and operate it. And there are several reasons that first, you need to build your healthy monitor. It cannot cover all the scenarios. Because the intelligent system is very, very complexity. You cannot cover all the scenarios. It's it's impossible. The second, huge overhead. Healthy monitor requires frequent cross-domain checks. It continually checking. It's a very, very performance overhead. So, and then expensive to load. First, you need to make your function to separate the whole function to 2 small functions. The one check another one. You need to rework your whole system. It's really a huge work. And then you need a safety kernel and hypervisor. It's, maybe just like the picture, the red part, you need a safety kernel just like microkernel or something else to check the green part. Green part is Linux. And you need a hypervisor. And then need more resource. CPU, memory, the chip need very power. So there are some companies address this solution. I think the solution is very beautiful. The architecture is beautiful. But when you want to build a production, it's really, really hard to build a production. Okay, option 3, and take a micro kernel-based OS. Everyone knows that. Okay, everyone knows that we can get a microkernel by 2 ways because microkernel is set field for ACOD. Yes, we can take a commercial production just like QNX, ACOD, Green Hill, etc. And also, if you have enough kernel guys, you can implement by yourself. Just like SEL4 is open source and L4RE, and our company built our own microkernel system, just like Homo microkernel, and we still get ACOD certification. I hold the project to certification by the microkernel, and it take about 1 year. Yeah, it's not expensive, but microkernel is not cheap. We want to say that it's not cheap and it's not free. That first one, ecosystem. As a microkernel, it means that it needs more function and API to support intelligent system, including Green Hill, including QNX, including our own microkernel. You need to do it by yourself. And second, 2 chains. Need more power 2 chains, just like Linux, because as a microkernel, you need to merge some perf. You need to build GDB, build perf by yourself. But in Linux, you can use it everywhere. Third one, expensive. And because microkernel, yeah, it's still a kernel, so you need a skilled kernel develop team or pay a commercial license. If you buy it, you need to pay it. If you build it by yourself, you need a team, skilled team. And certification, yeah, you need money and time. I think it's not a big problem to a lot of companies. So this is the whole system. If you have a microkernel, you have a different apps working together. That's a safety function and non-safety function. They are working together in the one operating system. Yeah, it's a perfect architecture. But just like it's not free and cheap. Okay, we can show our practical because this architecture we have implemented microkernel to integrate Linux kernel to build auto safety architecture. You can see the whole system, and of course in the down level is that microkernel-based hypervisor is already ACOD, and in the blue part is that microkernel RTOS. It will be used as real-time operating system. It could run cluster and safety controller, and just like the green part, you can run just like IVI. You can build how many OS? You can build IVI and just AGL in the green part. And the second green part is we will build smart driving. Smart driving system is L2 plus smart driving. The smart driving system is running on Linux kernel. Yeah, it's in the so the whole system architecture, we could separate the function, the safety function to the safety kernel, and the non-safety function we should put it in the Linux kernel. The whole system could work. Yeah, and this is the certification, and we announced the architecture already last year or this year. Yeah. Okay, summary. Linux, in my opinion, Linux is an effective solution for L2 plus smart driving system. Our view, as a smart driving, L1, L2, L2 plus will continue for a long time, more than 3 years. And so the entire system is still not deterministic. So the OS safety is not the first priority requirement for the current smart driving system. Then use Linux or microkernel depend on your business decision. You can use both of them. If you have your own microkernel, you can use microkernel. If you want to use Linux, it's okay. It's very good. And it can be seen that more and more companies will choose enhance Linux as the kernel or of their smart driving system. Because if you want to use the Linux to build your IVI or build your smart driving, you need to enhance the Linux kernel. There are a lot of opinions. We just give it. And you can by yourself give your own team to enhance your Linux kernel system. And if you enter the stage of autonomous driving, just like L3 and L4, the functional safety, I think, of the system must be raised to the first priority. It's very, very important. If you, our human, want to enter the stage of autonomous driving, at that time, safety field, microkernel-based OS, I think is the best choice at that time. but it's not now. Okay, the last. If you have enough resource, if you have enough money, if you're a company, you can use Linux integrate with the microkernel together. I think it's the best choice for your system. It could balance the ecosystem and the safety. Yeah, we can see Linux is good, microkernel is good. Both of them, how to use them is the key. It's very, very important. Okay, that's all. Any questions? Yeah, I can hear you.
I'd like to ask about your practical. Could you please show me the architecture?
Architecture?
Yes,
this is one?
Yes.
Okay.
There are nested microkernel. Long one is hypervisor and the microkernel. I said that the left one, blue one.
Left one?
Yes.
Okay.
Why? I think their brand application run directly to the micro-based hypervisor.
The green part and blue part.
Blue part.
Okay, blue part. Yes, blue part, you can, yeah, it's interesting that because microkernel and microkernel-based hypervisor,
yes,
they are separate. There are two components.
So micro-based hypervisor is just works as a hypervisor only.
But some, just like Unix, Unix already, the microkernel and hypervisor together. Maybe they are the whole component. But in our company, that we can separate them and we can make them together. It's no problem.
Yeah, yeah. I think I make it.
Okay. Any questions? Okay, I will stay here this afternoon, and any questions, welcome. Thank you.